Hello, hello. This is AQA's Foundation Tier, yet again GCSE Maths, for the November series 2017. So it's paper 1, the first one, the non-calculator paper. So let's have a look straight away at question 1. Question 1, circle the decimal which has the same value as 3/5. So what we could do for this one is a few things. We could say that 3/5 is the same as 6/10. We could multiply both top and bottom by 2, and we get 6/10. So if you can remember that the first unit after the decimal is a tenths column, that should hopefully show you straight away that it's going to be this one here. If not, what you could do is multiply both top and bottom by 10 again. 6 times 10 and 10 times 10. And what you'd get then would be 60 out of 100, which as a percentage means 60%. So 60% as a decimal is the same as 0.60. Because we don't need that 0 at the end. We could, if we wanted, just remove that final trailing 0. And so what we'd have would just be 0.6. So try and get that way. Hopefully you'd spot that 60% is the same as 0.6. And if you wanted to, just to make it a bit clearer, we could include an extra 0 at the end. 60%, 0.60. A third way I'm going to mention is we can think of a fraction, any fraction, as the top divided by the bottom. And so if we were to do 3 divided by 5 using the bus stop method, we would get the answer as well. Now we can make any whole number into a decimal number by writing a decimal point afterwards, plus as many zeros as we need, as long as a decimal lines up at the top and bottom. So first of all, 5's into 3. 5 is too big, so it doesn't fit. So we've got 0 5's into 3. So all of this 3 is still left over as a remainder. So remainder is 3. Now we've got how many 5's fit into 30. 5, 10, 15, 20, 25, 30, which would be 6. And because it's 6 exactly, we can stop. And so 3/5, which is the same as 3 divided by 5, is the same thing as 0.6. So that's why we need to circle the third option. Question 2, how many millimetres are there in 7.5 centimetres? So what you should have in front of you in the exam, really, is one of these things I'm going to get out here. A ruler. And so, with most rulers, in fact nearly all, they'll be measured in centimetres. So the top unit here is in centimetres, and the little tiny lines represent millimetres. And you should hopefully be able to count that there are 10 little divisions in each centimetre. The little divisions represent millimetres, and so we can say that 1 centimetre is made up of 10 millimetres. That's one of these metric conversions we just have to remember, I'm afraid, although in this case a ruler can help you out. 10 millimetres in each centimetre, 10 little lines, 10 little gaps between each centimetre. So using that fact, we can change from centimetres to millimetres fairly easily. This is a conversion relationship where one of the numbers is a 1, the other number isn't 1. So to change from one unit to the other, we just either multiply or divide by the number that isn't the 1, in this case 10. So if we're changing from centimetres to millimetres, we're going from a small number to a big number, so we'll be multiplying by 10. And so 7.5 centimetres can be changed to millimetres by performing 7.5 multiplied by 10. And that'll be the answer in millimetres. 7.5 times 10 would be 75 millimetres. And so that's the one we need to circle. Again, if you're not sure why 7.5 multiplied by 10 is 75, what you could always do, if you're unsure, is to do it as a multiplication, forgetting the decimal point. Ideally, you should be able to multiply by tens and hundreds without having to do this method, but just in case, you can always do it if you want to. So I'm just picking out the Chinese lattice method, which is one of many ways to multiply. And so if we did 75 multiplied by 10, we'd get 1 times 5, which is just 5, 7 times 1, which is just 7, and anything multiplied by 0 is obviously just 0. And so if we add up these numbers, as we go diagonally down, the first number is a 0. The next diagonal line to add up, 5 plus 0 is just 5. 0 plus 7 plus 0 is 7. And then we've got 0 up here, which is obviously just nothing. And so 75 multiplied by 10 gives us 750. But of course we weren't multiplying 75 by 10, we were multiplying 7.5 by 10. And so because we have one decimal place in the number we are multiplying, we'll also need one decimal place in our final answer. So we need one number coming after the dot, in this case the 0, and so our final answer would be 75.0, which should be 75. That seems quite a bit in depth maybe for question 2, but these are the questions which you need to be understanding really well. Don't make little mistakes early on. You need marks in the bank on the early questions before the questions get pretty hard towards the end. Question 3. Which of these shapes has 2 lines of symmetry? Semicircle, rhombus, trapezium, or isosceles triangle? And so what I've done here is I've just decided it'd be easiest if I just showed you each picture. So a semicircle is literally just half a circle, and this one would have one line of symmetry going straight down the middle. A trapezium might have one line of symmetry. If it were symmetrical, it could have a line of symmetry going down here if this side were of the same steepness as the other side, but in this case it isn't. So sometimes a trapezium will have no lines of symmetry. An isosceles triangle will always have one line of symmetry straight down the middle of it. But a rhombus will always have 2 lines of symmetry, one going across and one going straight down. And so the shape with 2 lines of symmetry would, in this case, be the rhombus. Got one line from top to bottom and another line going straight across. So that's the one we need to be circling. A rhombus is just a fancy name for what used to be called a diamond shape, but the technical name for a diamond now is a rhombus. It's like a square which has been pushed in at the sides slightly. Question 4. Circle the number that is 7 less than minus 12. And so 7 less than minus 12 is another way of saying minus 12 minus 7. And so you may have heard at various times that 2 minuses make a plus. That's true when the minus signs are together and touching, but in this case the 2 minus signs are separated by the 12. And so what we do here is we're starting at minus 12, we're then going lower by a further 7. We can think of this as if we take away 12 and then take away another 7, how much are we taking away altogether? The answer is we'll be taking away 19. So the one we need to circle for question 4 is minus 19. Another way we can picture this one is we start at minus 12 and we're going 7 less than minus 12. So we're going in the negative direction. We're becoming more negative. So minus 13, minus 14, minus 15, minus 16, minus 17, 18, 19 and 20. So because we're going 7 less, it means we're going down. So starting at minus 12, 7 less means 1 down, 2 down, 3, 4, 5, 6, 7. And the number we'd land on would be minus 19. And so that's just a different way we can picture it, but the answer to question 4 would be minus 9. And so that's the one we have to be circling. Question 5. Some algebra now in question 5, so let's get to it. So first of all, solve x minus 3 equals 14. And so one way we could do it is just simply by doing the opposite things to each side. The objective of equations is to just have the letter on its own equals whatever it equals. At the minute we've got minus 3 in the way, so what we could do is move that minus 3 to the other side of the equation. But if we swap side, we swap sign. Opposite of minus is plus. And so what we get here is that x must equal 17. Just to quickly show you another method, the flowchart method, we can start with the letter we're wanting to find out and then just take step by step, be thinking what happens to the letter. So the first thing that happens to x, in fact the only thing, is that we take 3 away. And after taking 3 away, we end up with 14. Now what we do is start at the end and work backwards, going the opposite way, doing the opposite thing. So start with 14, but move backwards. So because we're going the opposite way, we're going to do the opposite thing. So above we took away 3, opposite of taking away 3 is adding on 3. And so 14 plus 3 gives us x, which as I said before is 17. This method will only work if all the x's are on the same side of the equation, which they are here. There's no x's on the right hand side, so this method will work fine. 5b. Solve 5y equals 45. So what this means is 5 is multiplying y. So we don't know what y is, do we? One way we could do it is just by trying different numbers. So 5 multiplied by some number gives us 45. So we can just sometimes be thinking, well, what number would work? How many 5s would make 45? Well, it's got to be 5 times 9 that works. And so y must be equal to 9. Using the way I mentioned in part A, we can think about what is the 5 doing to the y. In algebra, if we've got two different things just next to each other, with no instruction telling us what's happening, it will always mean one is multiplying the other. And so the 5 is multiplying the y. And so if this 5 swaps side, it will swap sign to the opposite operation. And the opposite of multiplying will be dividing. So y will be 45 divided by 5, which, as I said before, is 9. Also as well, a different way of doing this, like I mentioned before, would be if we used a flowchart. So if we start again with the letter we're trying to find, so this time we're trying to find y, And what happens to y is that the 5 is multiplying it. And after being multiplied by 5, we get 45. Now if we reverse the step, start at 45, and go the opposite way, doing the opposite thing, we can get back to what y must have been in the first place. So 45 divided by 5, again would give us that y must have been 9. Part C, we have that 8 plus w equals 6. So again, I'll just jump into doing the flowchart diagram method again straight away for this one. So if I were to do that, then we've got w, and the first thing that happens to w is we add 8 to it. And the answer to that is that we get 6. And so if we start with 6 and go backwards, then instead of adding 8, we'd be taking away 8. So 6 take away 8 would take us all the way back to minus 2. So w would have to be minus 2. If you think about it, if we start with 8 and we add on a number, whatever the number must be, if we add a number on and the overall answer gets smaller, we must have added a minus number. 8 plus any other normal number would give an answer bigger than 8, so it's got to be a minus number. 8 has gone down 2 to get to 6, so this value here must be minus 2. That's just another way you can think of it. Question 6a. Work out 9,174 divided by 11. So division questions can almost always be tackled using the bus stop method. And so the number we're dividing by goes on the outside, the number we're dividing goes on the inside. And we just treat it number by number. How many times can we fit this number into 9? So how many times does 11 fit into 9? 11 is too big, so it doesn't fit into 9 even once. And so that 9 is left over. By the way, what it might help you to do is the number you're dividing by, you could always do the times table of that number just to the side of your page. So I'm just doing the 11 times table all the way up to 9. So we can see here how many 11s fit into 91 by just looking down. 1, 2, 3, 4, 5, 6, 7, 8. So we can fit 8 11s into 91. 8 11s is 88, which is still 3 away from 91. And so the remainder is 3 this time around. Then 11 into 37 goes 3 times. 3 11s are 33. So we've got a remainder of 4, because 33 is 4 away from 37. And finally, 11s into 44, 1, 2, 3, 4, goes 4 exactly. And because there's no remainder, because it fits exactly, we can stop. And so this is our final solution. This is our final answer. And so 9174 divided by 11 is 834. Part B, work out 5/6 plus 3/7. Give your answer as a mixed number. So I'm just going to copy out the question here. One thing we need to do is to have the denominators the same when we're adding together fractions. And one quick method, which will always work, is this method I'm just going to show here. So what we could do is just multiply the bottom numbers together. So 6 multiplied by 7. And what we do with the other numbers is we replace the plus with a big cross. We're going to do 5 times 7 and 3 times 6. Whereas also we're going to be multiplying the bottom numbers together too. And so this cross multiplication here gives us the new top numbers. So the new top number, instead of 5, will be 5 times 7, which is 35. And the new bottom number, 6 times 7, is 42. And this new top number, instead of being 3, will be 3 times 6, which is 18. And the new bottom number, 7 times 6, again, is going to be 42. And so how we found those new top numbers, just to go back to that point, we just cross multiply. So 5 times 7 gives us 35. And then we did 3 times 6 to give us 18. And we multiply together with the bottom numbers, and that's how we get the 42. Now we've done that, and the bottom numbers are the same, we can leave the bottom numbers alone and just look at the tops. So we just do 35 plus 18 now to work out what the new top number will be. So we can do this over here just out of the way. 5 plus 8 is 13. Carry the 1. And then 3 plus 1 is 4, plus the 1 we've carried would be 5. So 35 plus 18 is 53 over 42. And then because the question asks us for a mixed number, what we need to do now is to change this back into a mixed number. So what we do now is think, how many times can we fit 42 into 53? And the answer is 1. And then what would the remainder be? 53 take away 42 would give us 11. So 42's into 53 goes once, remainder 11. So how many times it goes in gives us the whole number. What's left over gives us the new top number. The bottom number would stay the same, however. And so that's the answer as a mixed number like we wanted all along. So the final answer we need to put down is 1 and 11 over 42. On question 7, we've got a diagram showing the scores given by judges during a television show. In the first part of it, we need to find what the mode was. We need to remember the definition of mode. Mode just means the most common, and so in this case a mode is going to be the most common score. The score which the judges gave out most. So we can get this information from just looking at the graph. So the mode is going to be the score of the highest frequency. So it's going to be the one with the biggest bar, which is this one here. So the modal score will be 4, because more 4s were given than any other score. For example, 0 wasn't given at all, but 9 4s were given out in total. So the mode is 4, and that's what we need to write down for our answer. For part B, we're told that there are 4 judges, and each judge gave 1 score out in each round. So if you think about that for a second, if there are 4 judges and each judge gave 1 score in each round, and that means that each round, if each judge gives one score each round, and there's 4 of the judges, each round means 4 scores are given. So what we need to do here is to calculate the grand total of how many scores were given out. So 0 was never given out. The score of 1 was given out 3 times. A score of 2 was given out 6 times, as was a score of 3. A score of 4, which we said before was a mode, was given out most at 9 times. And finally, a score of 5 was given 4 times. So what we need to do now is to think about the total scores. So the total scores, total number of scores, is 3 plus 6 plus 6 plus 9 plus 4. So if you just do this number by number carefully, 3 plus 6 is 9. 9 add another 6 is 15. 15 added to another 9 is 24. And 24 plus a final 4 is 28 scores. So 28 scores were awarded in total. So now if we just return to what we said earlier about with each round 4 scores are given out. So if it were 1 round, that would be just 4 scores. But here we've just calculated, by adding them all up, that actually there were 28 scores in total. So if it weren't just 4 scores, there were 28 scores. So how many rounds must there have been to get 28 is what we're having to find out. Now we can do this using a direct division by just thinking how many times does 4 fit into 28? How many 4's in 28? We can do our 4 times table if we wanted. 4, 8, 12, 16, 20, 24, 28. There's 7 4's in 28. And so if we had 7 times as many scores as 4, that means we had 7 times as many rounds as just for 1 round. And so 1 multiplied by 7 shows us that there must have been 7 rounds. So the final question, when it says how many rounds were there, well, the answer to that one is there were 7 rounds. I'll give you a different way of thinking about it, if that's still slightly confusing. So, if I just move over here for a second, what it means is each time there's a round, there's 4 different scores given by each judge. So first round, judge 1, judge 2, judge 3, judge 4. Round 2, judge 1, judge 2, judge 3, judge 4. Round 3, and so you can keep doing this again and again until you finally get to a total of 28 scores that have given out. And you'd find that after doing this. And so that'd be round 1, round 2, round 3, round 4, round 5, round 6, and round 7 would be the 28th score given out. So the final answer, there must have been 7 rounds altogether. Question 8, a library book was due to be returned on the 27th of September, and it was actually returned on the 14th of October. There's a fine of 8p for every day the book's late. Work out the total fine. Well, This can be confusing, especially because different months have different days. And so in September has 30 days. Whereas October has 31 days. So you need to know this bit of information for this question. There is actually a rhyme for remembering how many days in each month. So I'll embarrass myself by just quickly mentioning it, but I'd suggest Googling it as well because you do need to know it. It goes along the lines of 30 days have September, April, June and November. All the rest have 31, except February alone, which has 28 days clear, except 29 days in each leap year. And so the months that have 30 days are September, April, June and November. So apart from February, which has 28, unless it's a leap year, all the other months will have 31 days. Anyway, I've digressed a bit anyway from the question. So what we could do here is actually think of this as the table in a way. So if I just reveal this. Now, it was due to be returned on the 27th of September. So if it were returned on the 27th, that would have been just in time. That wouldn't have been late at all. Would have been barely on time, but wouldn't have technically been late. So we can start by saying that wouldn't have been late at all. The first day late would have been the 28th of September. 29th would be the second day late. Then the 30th of September would be 3 days late. After the 30th of September, the next day is the 1st of October. So we can just build it up like this. I'm not saying you should necessarily take the time to draw a perfectly neat table in your exam, but you can do like a very rough version if it helps you to work it out how many days the book was late. And what you should come to eventually is that the book was 17 days late. So the book was 17 days late. Now, for each day the book's late, there's an 8p fine. And so the total fine is going to be 8p multiplied by 17. So we can do this in a few different ways. It doesn't particularly matter which way you pick as long as you arrive at the final answer, which is correct. I'll just do it this way, which is the Chinese method. So 17 is a 2-digit number, so do 2 rows, and 8p is just 1 digit. Now what we do is split the squares, going from corner to corner, and now we just work out what each multiplication is. So 7 multiplied by 8 would be 56, and 1 multiplied by 8 would just be 8. And so now if we add up these numbers going diagonally downwards, the first one will just be the number 6. The next diagonal, 5 plus 8 is 13. Carry 1 over. The final one was 0, but plus this carried 1 would be 136. And so the total fine, which is 8p multiplied by 17, would be 136 pence. But because our answer wants pounds and pence, we need to convert that to pounds and pence. So 136 pence would be £1 36. And that's it for question 8. Question 9, we're told about a game that has 3 stars hidden at random. Each star is behind a different square on the board. And so what we need to do really is have a look at this board. Each row's got 5 squares, and there's 5 different rows. And so 5 times 5, we've got 25 squares here. So part 8 says a square is chosen at random, and we're asked what the probability is that there's a star behind it. And so the probability of picking a star that's going to equal the number of ways we could do that, basically the number of stars there are, picking a star can only happen if we pick one of the squares which has a star, so that's going to be the number of stars there are in total, divided by the total number of possible options we have if we pick a square at random. So that's going to be divided by the total number of squares. So we're told how many stars there are. So for the number of stars, we're told there's 3 stars. So first of all, the number of stars is 3. There's going to be 3 out of a total number of squares, which we just worked out earlier by having a look at the grid. There's 25 squares in total. And so the total number of squares is going to be 25. And so probability, we're fine expressing it as a fraction. And so there's a 3 in 25 chance of picking a square with a star behind it if we pick a square at random. And so that's it really for part A. It's just 3 out of 25. Part B, in one game the stars are behind 3 consecutive squares. Okay, so I'm just going to try and just run through what this means. So 3 consecutive squares, all that means is the stars are in a line. So the stars are together. In a line. It says the squares are in one row or one column. So that means that they're in a row going across or a column going down. So the stars can't be diagonally together. So we're told that one of the squares is E2. So we can use that information to help us. So one of the squares is E2. E2 means one with E above it and 2 by the side. So I'm just going to put a little cross over E2. So we know one of the stars is there. It says write down other possible pairs for the other 2 squares. And so if one of the squares is definitely on E2, that means that we could have, for example, the other 2 squares here. So one possibility is that the other 2 squares are in C2 and D2. The other possibility as well is that the other one, the other 2 squares, may be down here. If they were down here, they'd all be in the same column going down. So another option is that the other two squares could be in these two here. So that would be E3 and E4. Or apart from that, there's another option as well, and the other option is that the other square, sorry, the other squares could be this one and that one. So you'd have three in a row. So the square in E2 might be in the middle with one star at the top of it and one square below. So the final option is E1 and E3. So that's what we need to be putting down on our answer line. So it could be C2 and D2. We could have E3 and E4. The final combination, it could be E1 and E3. Question 10. We need to complete the table to show the equivalent fractions and percentages. So the first one we need to work out is what would 3/10 be as a percentage? Well, percentage means out of 100. So 3/10 as it stands is a fraction out of 10. So how can we go up from 10 to 100? What could we multiply 10 by to get to 100? The answer is we could multiply by 10. But if we do something to the bottom number, we need to do exactly the same to the top. And so we'd need to do 3 times 10. So an equivalent fraction to 3/10 is 30 over 100, which by definition, because this is a fraction out of 100, that means 30%. So 3/10 we can say is 30%. And 43%, just looking here, 43%, just remembering that percentage means out of 100, that just means 43 out of 100 therefore. Check if it simplifies down. I don't think it does, so just we put this one in here, so 43 out of 100. And finally, 5 over 2 just be aware 5 over 2 is a top-heavy fraction. This represents a number bigger than 1. So as a percentage, 1 unit is 100%. So this is going to be bigger than 100%. But we can use the same method we did for 3/10. What we could do is try and see how we can get from 2 up to 100. We can do this in steps, or we can do it directly. We just need to make 2 bigger. So what we could do is make it into 20 by timesing it by 10. But of course, if we multiply the bottom by 10, like I said before, we do the same to the top. So 5 times 10 would be 50. But of course, it's only a percentage if the bottom number is 100. And so can we go from 20 to 100? The answer is we can, because if we do 20 times 5, that gets us to 100 exactly, because 5 20s makes 100. But the same way as what we did before, to the bottom we do to the top, we do the same thing here. This time we multiplied the bottom by 5, so now we need to multiply the top by 5. 50 times 5. Well, 5 times 5 is 25. Add on the 0, we get 250. And because this is now a fraction out of 100, that means 250% by the definition of what a percentage actually is. So this final one here will be 250%. You'll get a mark for each one of these you correctly convert. So the first one, 3/10, is 30%. Just to recap. The second one, 43%, is the same as 43 out of 100. And the last one we did, 5/2, 5/2, will be 250%. Another way you could think of the last one is that 1/2, for example here at the top, is 50%. So 5/2 will be 5 times as much. 50 times 5 is 250%. And so you could have even used the information we were given to help you. But to be honest, as long as you can understand how to get them in your own way, that's all you should really be concerned about. That's question 10 done. Question 11. Cards in a pack are red or blue, and the ratio of red to blue is 2:3. And we're asked what fraction of the cards are red, and we have to circle the answer. So we do have multiple choice questions peppered throughout the paper, but what I've done here is just a fairly simple diagram just showing how you could maybe picture it. So if 2 lots are red and 3 lots are blue, then we can picture the total number of cards being 5 lots. Ratio splits things into equal sized lots. So if 2 lots are red and 3 lots are blue, we have 5 lots altogether. And out of those 5 lots, we can say that 2 out of 5 are red and 3 out of 5 are blue. And so because we're asked for what fraction of cards are red, it's 2 out of 5, it's 2/5. So that's the one we need to circle. Part B, we're told that a different pack has 72 cards and that 5/9 are yellow. We need to work out the number of yellow cards. And so what we need to do here is find a fraction of an amount. So we're finding 5/9 of 72. And so what I'd suggest we do first of all is to find 1/9 of 72, which we can do by doing 72 divided by 9. So this is finding what 1/9 is. So how many 9s fit into 72? The answer to that is 8. And then once we found what 1/9 is, we then want 5/9, so multiply it by 5. So 72 divided by 9, we said was 8. Then times that by 5. And 8 times 5 is 40. So 40 of the cards are yellow. I'll show you another way which isn't as easy for this question, but it's worth remembering, especially later in the paper. This method will come in use for question 16. We can find a fraction of an amount by doing this fraction of 72. Of often works in maths as a multiplication, but if we're multiplying a fraction by a whole number, just remember we can make any whole number into a fraction by writing the number over 1. So 72 is exactly the same as 72 over 1. Now what we can do is multiply a fraction by another fraction by just multiplying across. As I say, this method isn't the easiest. I think this one we did earlier is easier, but just to show you how it would work. So 5 multiplied by 72 at the top. So 5 times 2 is 10. Carry the 1. And the next one, 5 times 7 is 35, plus the one we just carried is 360. And so 5 times 72 is 360. And 9 times 1 is 9. And finally, if we do 360 divided by 9, well, 9 into 3 won't go, and so that 3 is still left over. When 9's into 36, we can fit 4. And finally, 9's into 0 doesn't go at all. So 360 divided by 9 is 40, which is what we had earlier. So what I'm trying to do there is to show you how the two methods are equivalent. So to find a fraction of an amount, we can just take the whole number, divide by the bottom, multiply by the top, or we can convert the whole number into a fraction and treat it as a fraction multiplied by a fraction. So there are two different ways we can do it. Question 12. This is about shapes. So we were asked first of all for part A, how many edges are there on a square-based pyramid? What I've decided to do is just to remind you what a square-based pyramid would look like by just getting a diagram of one to hand. And so edges of a shape are just the straight lines that join the corners, that join the vertices. So when we're talking about edges of a shape, we can just note these down here. And so this bottom edge is 1. There's a side one here, which is a second edge. 3. And 4. So around the square base, there's 4 edges, because the square has 4 edges. But then there's also 4 more, because joining the bottom corners of the square to the top point is another 4 edges. There's one, a second one at the back, a third one at the front, and finally a fourth one going up the side. So the total number of edges would actually be 1, 2, 3, 4 around the sides, and 4 at the bottom for the square. 4 plus 4, that gives a total of 8 edges. So we need to circle 8. Part B, a similar question, but this time we're asked about a triangular prism. And so in the same way, what I've decided to do is just remind us what a triangular prism is by revealing one here. And hopefully this will make it quite clear that there's only 2 faces which are triangular on a triangular prism. And those faces have a front face and a face at the back. So these 2 faces, the front and the back, are triangular. All the other faces for a triangular prism are actually going to be rectangular. And so just 2 faces that are triangular in a triangular prism. Question 13. A bus can be early, on time, or late. So let's just note that down. It can be early, on time, or it can be late. Now this is a probability question where we need to remember something. For something we need to remember is that for any event, the sum of all probabilities for all possible outcomes for any event add up to 1, or the sum is 1, I could have just said. And so early, on time, late, these are the 3 different options. A bus is either early, on time or late, so that covers all possible options. And so early is 0.1, on time we've got 0.6, late, that's what we need to be working out. And so what I said before about the sum of all probabilities adding up to 1, we need to apply here. So these three probabilities, early plus on time plus late, will have to add up to 1 based on what I've said here. The sum of all probabilities will have to add up to 1. So just taking this here, so 0.1 plus 0.6 plus L for late, I've just called it. You can call it anything if you want. They'll all add up to 1. So before we work this out, we can simplify it slightly, because we can work out ourselves what 0.1 plus 0.6 is. 0.1 plus 0.6 is 0.7. That equals 1. And so 0.7 plus something equals 1. And so what we can do here is just work out what L is by taking away 0.7 from 1. Again, it's a case of swapping side and swapping sign. Opposite of adding 0.7 is we can treat that as subtracting. 1 take away 0.7 would leave us with 0.3. So the probability that the bus is late must be 0.3. Now if you wanted to write it as a fraction, you could do. I don't know why you would, but you could say that's 3/10 if you really wanted. So either or. Question 14, we've got a graph to draw, and the graph is x plus y equals 2. And the values of x we need are from -3 to 3. So we could do a table of values, or we could just think of different values for x and y that would add up to 2. The only criteria we need is whatever x is and whatever y is, it's got to add up to 2. And so all we need for a straight line graph, by the way, this will be a straight line graph because it's got no x squareds and no y squareds in it. All you need for a straight line graph is 2 points really. 2 points, a straight line through them, and you're done. And so can you think of two numbers, x and y, where you add them together, you get 2? I'd say maybe the most obvious would be 1 and 1, because 1 plus 1 equals 2. Or we could say a few more. If x is 0, y could be 2, because nothing plus 2 equals 2. Or maybe x could be 2. And if x were 2, y would have to be 0, because again 2 plus 0 equals 2. And so these are just possible points we could have, because all these would meet the criteria that x plus y equals 2. So I did say we only need 2 points. What I've done here is 3 separate points, in fact. Not just 2 points, but 3. So the first point is that x could be 1 and y could be 1. Second point is when x is 0, y could be 2. And the third one I've shown here is that when x is 2, y could be 0. And so if we draw these points on our line now, on our graph rather, x1, y1 would be this point here. X is 0, y is 2 would be this point here. And the final one, when x is 2, y is 0, would be this point down here on the x-axis. And as I say, all we need is a straight line going through these points, and we need to make sure it goes at least from -3 to 3. So straight line we have to draw would have to look something like that. So it's a straight line going through all the points, and that will do for question 14. Now, you could, as well, as I mentioned, plotted a table of values. You wouldn't have to, if you wanted to, maybe as your teachers told you. That again is a perfectly valid way of tackling this question too. Question 15. 5% of a number is 31, and 1% of the same number is 6.2. We're asked to work out 13% of a number. So 13%, we've been given some percentage parts already, so what we could do is build up using these building blocks to 13%. 13%, we could do 5% plus 5% plus 1% plus 1% plus 1%. Because we've been told what 5% is. 5% is 31. We've also been told what 1% is, because 1% is 6.2. And so for this one, we can just treat it as an addition, if you'd like. So 5% is 31. So 2 lots of 31. 1% of the same number is 6.2. Now, this is a decimal number. 31 is the same as 31.0. So if it helps, we can make all the numbers into decimals by just putting a 0 after the decimal if it's a whole number. Now we've got decimal points which can be lined up. When we're adding or subtracting using decimals, it's really important that the decimal points add up at the top and the bottom. So we've set it out. We've got 2 lots of 5%, and we've got 3 lots of 1%, like I said above. So now the only thing we need to do is just to do this addition. So starting on the right hand side, nothing plus nothing is nothing. Plus 2 plus 2 plus 2 would be 6. Make sure the dots line up at the bottom as well. Now we've got 1 plus 1 is 2, plus 6 is 8. 8 plus another 6 is 14, and 14 plus this final 6 is 20. And so we put down a 0, and we need to carry the 2 over. So now finally, 3 plus 3 is 6, plus the 2 we've just carried is 8. And so the final answer for this one would be 80.6. It's not the only way of doing the question, but it is a way which will work. I'll show you another way just for the hell of it. 13%, you can think of that as being 1% 13 times. And so if we know what 1% is, which is 6.2, we could just do 6.2 multiplied by 13. So if we treat 6.2 as 62 for now, multiply it by 13, this is just an alternative method. You don't need to do both, you don't even need to understand both, but you do need to understand one way at least. So 2 times 1 is 2, 6 times 1 is 6. And over here, 2 times 3 is 6. In this final box, 6 times 3 is 18. Now we add up the numbers going diagonally down. So the first one is a 6. The second diagonal row, 2 plus 0 plus 8 is 10. So put the 0, carry 1 along. Then this final one, because that 0 doesn't matter at the end, 6 plus 1 is 7, plus the one we've just carried is 8. And so what we'd have there is 806, but of course you need to remember that there was a decimal point in the question. 62, I actually mean 6.2 if you put the decimal back in. If there's one decimal point in the question, we need one decimal point in the answer. And so the decimal needs to go before the 6, which would make it 80.6. Question 16. Complete the grid so that when you multiply the three numbers in any column, row or diagonal, the answer is 1. Wow, this is a question that could really potentially freak you out, because this is a very unstructured question with no obvious way of where to start. What I'd say though, first of all, is if we have a look at this bottom corner here, as the question says, each column, row or diagonal, when you multiply the three numbers, it needs to add up, so it needs to multiply to give us 1. So if we look at this bottom row for a second, just looking at the bottom row, just mentioning here, 2 times 5 times whatever, because we don't know what that is, we could call it X or Y for yellow, doesn't really matter, but 2 times 5 times this one has to equal 1. Now we can neaten this up a bit, because we can do 2 times 5, which is 10. So 10 multiplied by whatever the mystery one is gives us 1. And now we can solve it as a equation. So whatever this number is, when we multiply it by 10 we get 1. We want to know what the question mark is on its own, so what we can do is get rid of this 10 by swapping its side. We can rearrange this equation, but if we swap the side of something, we swap the sign. That 10 was multiplying the question mark, opposite of multiplying would be dividing. So therefore, the question mark is 1 divided by the 10 we've just moved. Now, we could write a division as a fraction. So we can just say it's 1 over 10, because 1 over 10 means 1 divided by 10. So we've got 1 there. Now where do we go? Well, we could have a look at the top. Again, you can do the boxes in any order, it doesn't really matter the order you pick. But I'd suggest trying to pick the easier ones first. So looking at the top, if I just colour this in green, so if we just consider the top row now, then 10 multiplied by whatever, multiplied by a half, that has to equal 1, because as we said before, when you multiply all the numbers in the same row, it needs to add up to 1. So if the order you multiply, you need to know it doesn't matter. For example, 2 times 4, same as 4 times 2. 8 times 3, same as 3 times 8. So here what we can do is we can simplify this up a bit by doing 10 multiplied by a half first. 10 times a half means what would 10 halves be? If we had 10 halves of a pizza, that would be 5 complete pizzas altogether. So 10 times a half, or half times 10, you can think of as being half of 10, which should be 5. So just neatening this bit up here, 10 times a half becomes 5. So 5 multiplied by the mystery number would give us 1. Now in the same way as the bottom row, we need to just find what the question mark is on its own. So we need to rearrange this equation again. So that 5 can be taken to the other side of the equation. That 5 is multiplying the question mark. Opposite of multiply is divide. When we swap side, swap sign. So for this one, the question mark here is 1 divided by 5, which we can leave as a fraction, just like we did for the first one we did. Now we can do the middle. Now we can do it if we want for the middle. We can look at this middle column, or the middle row, or even any diagonal. What I'm going to suggest is just picking the smallest, easiest numbers. Let's have a look at the diagonal from this corner to this corner. That diagonal there. So I'm just going to colour this in a lovely aqua. And what I want you to consider with me now is the bottom left to the top right diagonal, the one I just highlighted earlier in the red line. So whatever this one here is, when we multiply the numbers in this line together, 2 times a half times the mystery number needs to equal 1. Now 2 times a half, 2 halves would make 1. So this bit, 2 times a half, we can just simplify and say this bit equals 1. So 1 times the mystery number equals 1. Now this is just really straightforward. What do I multiply 1 by to get 1? It's got to be 1, because 1 times 1 equals 1. So for the middle one, the mystery number is just simply 1. It's a question type which you probably haven't seen much of, because it's one of these sort of problem solving ones. But as long as you keep your head and just think, what do I know, and take it from there, you should find that it's not as bad as what you initially may have imagined. That's question 16 done. Question 17. A sequence has only 3 terms, so that just means it's got 3 numbers in it. The term-to-term rule for the sequence is multiply by 8 and then add 11. That just means what we do to the previous number to get the next number. So the first term, the first number of a sequence is -1. Work out the third term. And so whatever the number is, in this case -1, the first thing we do is we're told we multiply it by 8. So what we need to do is take -1 and times it by 8. Well, 1 multiplied by 8 would be 8. So -1 multiplied by 8 would be -8. The next step, we're told to add 11. So minus 8 plus 11. Minus 8 plus 11 would actually be 3. I'm going to try and show you why that's the case. And so if we start at minus 8, if we take a number line here, and we start at minus 8, we're going to go 11 along, because plus 11 means we're going to go 11 to the positive side. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to start at minus 8, and we're going to hop 11 numbers to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1 bigger than minus 8 is minus 7. They go minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, then we're at 0, then 1, 2, and 3. And so the first term is minus 1, the second term is 3. So what we can do now is the same process to generate the third term. So start with 3, but now we're going to do the same steps. So again, multiply by 8, because that's what we're doing all the time for each term-to-term rule. So multiply by 8, and after multiplying by 8, you guessed it, we're going to add 11 on. So first of all, 3 multiplied by 8 is 24. Then add 11. 24 plus 11 would give us 35. And so that's what the third term is. The third term is 35. So we need to just put that on our answer line. Part B, it says the order of the 3 terms from Part A is reversed to make a new sequence. And so if it were reversed, the last term was 35. The second term, we said it was, I believe, 3. The first term, which is now the last after reversing the order, is minus 1. So the term-to-term rule for the previous sequence was you multiplied by 8 and then added 11. Now because the order of the 3 terms is reversed, that will alter what the term-to-term rule for this sequence now is. Because we've reversed the order of the terms, what will actually happen is we'll be doing the exact opposite. And so in some order, instead of multiplying by 8, we'll be dividing by 8. And adding 11. Sorry, instead of adding 11, we'll be subtracting 11. We've tried this one, 35 divided by 8, that's going to be a decimal, so it can't be dividing by 8 first. In fact, what it is we're going to subtract 11 first, and then divide by 8. 35 take away 11 is 24. 24 divided by 8 would give us 3. And so, first of all, we're going to subtract 11. And then after that, then we're going to divide by 8. So another way you can think of this is the previous process, we were multiplying by 8, and then we added 11. Whereas now we're going the opposite way entirely, starting at the opposite end and doing the opposite things. So opposite of adding 11 is minus 11, and the opposite of timesing by 8 is to divide by 8. So because we start at the opposite end, we're going to subtract 11 first, and then divide by 8. And so that's the order of what we're doing things. So the term rule is subtract 11, and then we're going to divide by 8. And that's question 17. Question 18. We've got a quadrilateral and we show that an angle is equal to 100 degrees. So what we can do is apply some angle facts to this. And so the angle at A on the other side of A is 70 degrees. And so what we can do now is say for definite that the one on the other side is also 70 degrees. And so why is that the case? Why can we say that? Well, the thing I'd look for is letters of the alphabet. And so in my head, this is an X angle. Now X angles are called vertically opposite angles. Now the angle I've just filled in here is at A, and it's D to A to B. So what we can say here is angle DAB equals 70 degrees. What we need to do is prove that angle X is 100 degrees. So we need to state the angle facts we're using, if we are using any. And so that's 70 degrees because a fancy word for X angles is vertically opposite. So vertically opposite angles are equal. So that's all well and good, but it says ABCD is a quadrilateral, and so what you need to, well in fact no, I was going to lie then. I was going to say you need to remember that a quadrilateral, angles inside a quadrilateral add up to 360 degrees, but I'll just bite my tongue there. I'll show you a way around it. You can think of any shape as a number of triangles glued together. What you do need to remember is that angles in a triangle add up to 180 degrees. And so you can think of this quadrilateral ABCD as two triangles stuck together. If so, that triangle here would be 180 degrees. This one here would be 180 degrees. In total, 180 plus 180 would be 360. And so the main thing I'm trying to get at is the fact that the total of all the angles inside ABCD will have to add up to 360. And so this one over here is the one we need to work out, because we know the others. So if we can work out this one, we can then work out X on the other side. So the next thing to mention is 70 degrees. This one's 70. This square means a right angle, which will be 90. This one here, plus 120. Plus the angle at B, which is at corner B from A to B to C. So we can label this angle ABC. It's always the middle letter. That'll add up to 360 degrees. Because angles inside a quadrilateral will add up to 360. You can think of a quadrilateral as two triangles glued together. So 70 plus 90 plus 120, well we can work out of this would be 70 plus 90 plus 120 0 plus 0 plus 0 is 0. 7 plus 9 is 16. Plus 2 would be 18. So put the 8 down and carry 1 over. And finally 1 plus 1 is 280. And so these numbers here, 70 plus 90 plus 120, add up to 280. And so 280 plus whatever ABC is will equal 360. Now the final step with solving this would be to subtract 280 from 360. So if we swap side and swap sign and do 360 take away 280, so you can do column subtraction if you want to, but I'm just going to skip ahead and say that ABC, if you were to do 360 take away 280, you'd get 80 degrees. So we can label this on the diagram now. ABC is 80. But if you notice, 80 plus x are on a straight line. Now again, what you need to remember is that angles on a straight line add up to 180 degrees. And so 80 plus x equals 180 degrees. Angles that touch together on a straight line add up to 180. But the two angles need to be touching. So we can't say that 70 plus 80 plus x equals 180 because they're all on a straight line. It's got to be angles that are meeting at the same point and on the same side of the straight line. And so if 80 plus x equals 180, again we can solve that equation by just moving the 80 to the other side and swapping side, swapping sign. So therefore x will be 180 take away 80, which is going to be 100, which is what we wanted to prove in the first place. And so using some angle facts and some geometry, we've proved that x is 100 degrees, like we needed to. And that's question 18 done. Question 19, we've got a conversion to do from gallons to litres. We're asked to convert 17 gallons into litres. I'm going to show two different ways. I'm going to show two different ways of tackling this question. And so one thing we can do is to just build up from 2 gallons all the way to 17. So if what I do here, just say gallons on one side and litres on the other, what we can do is just build up step by step. So we're told 2 gallons equals 9 litres, and so we can just write that down straight away. So if we had 4 gallons, add another 2, that'd be the same as 18 litres. 2, 4, 6, 9, 18, 27. What we're going to do is just build up step by step, adding another 2 gallons on this side each time. But because 2 gallons is the same as 9 litres, this side we're going to be adding on 9s. And so what we're doing in effect is the 2 times table for the gallons and the 9 times table for the number of litres. So we're just building it up and up until we get to where we need. Add another 2, add another 9. Add another 2, add another 9, add another 2, add another 9, and then add another 2, add another 9. So 16 gallons is 72 litres. But now we just want one extra gallon, because 16 gallons is what we have. We need an extra 1 gallon. So if 2 gallons is 9 litres, what we could do here is figure out how much 1 gallon is by just dividing both sides by 2. Half of 2 gallons is 1 gallon, and half of 9 litres would be 4.5. So 1 gallon equals 4.5 litres. And so adding on a final gallon here would take us to 17. So 1 gallon is 4.5 litres. And so if we do 72 plus an extra 4.5, that would take us to 76.5 litres. So that's our answer, 76.5 litres. I'm now going to show you how you can do it directly without this build-up method. Just going back to what we had earlier, 2 gallons equals 9 litres. If we just want to work out what 1 gallon is, like we did before, if we divide both sides by 2, that tells us that 1 gallon is 4.5 litres. And we get this by just dividing both sides by 2. So now we know what 1 gallon is. To go to 17 gallons, we can simply just multiply by 17. One times 17 gives us 17 gallons. So what we need to do here, the hard bit, is 4.5 times 17. So what we can do is a method to do multiplication of 4.5 multiplied by 17. So I call it 45. Forget the decimal for now. We can put that back in after. 45 multiplied by 17. And now we can split this from corner to corner like this. So first of all, 5 times 1 is 5. 4 times 1 is 4. In the bottom row, 5 times 7 gives us 35, whereas 4 times 7 is 28. Now we can add up these numbers going diagonally downwards. So the first one is just 5. Then here we've got 5 plus 3, which is 8, plus this 8 would make 16. So put 6 down, carry 1 along. Now we've got 0 plus 4 plus 2, which is 6, plus this one, which would be 7. And 0 at the top left corner, so we don't need that. But just bear in mind, it wasn't 45, it was actually 4.5. And so we had 1 decimal place in our question, which means we need 1 decimal place in our answer. And so the decimal needs to come before the 5, which again, as before, would give us a final answer of 76.5. So a couple of different methods I've shown you there, but 76.5 is the final answer you should have. Question 20. N is an odd number and P is a prime number. So we've got different parts to this question. For part A, we need to show different values of N and P so that N plus P is a square number. So there's going to be multiple different options for this. First of all, what I'm going to do is think about different odd numbers. So odd numbers would go on for a long time. So let's just do a few. 1, 3, 5, 7, 9, 11, 13, 15, and so on and so on. You don't need to do loads, but maybe up to 20 or something. So we keep going on. And prime numbers are numbers that can only be divided by two things. They can only be divided by themselves and by 1. The first prime number is 2. Now 1 isn't prime because there's only one thing that divides 1, which is 1. Anyway, 2 is prime, as is 3, as is 5, 7 is also prime. 9 isn't, because 9 you can divide by 3. 11 is. 13 is. 15 isn't, because you can divide it by 3 and 5. Next one will be 17. 19. 21 isn't, because it can be divided by 3 and 7. And then 23. So again, these would carry on forever and ever. So what we've got is odd numbers here. And prime numbers I've just listed underneath. So first of all, we need to pick two of them so that n plus p is a square number. Bear in mind though here, it doesn't say that n and p need to necessarily be different. All it means that n must be an odd number and p must be prime. So one thing we could pick, just looking at this, we could go for 1 and 3. Because 1 plus 3 equals 4, and 4 equals 2 squared. There's different options as well. I mean, we could have also picked, let's have a look, we could have picked, for example, 9 and 7, because 9 plus 7 is 16, and 16 is the same as 4 squared. Now, you don't need to be looking for loads of different options. All you need is just one. Remember, it's a one-mark question at the end of the day. So I think the easiest one might be just to say n could be 1, p could be 3, because 1 plus 3 is 4, and 4 is a square number. Now, for part B, we need to be thinking of odd numbers and prime numbers so that when we multiply them together, np is a square number. So I'm just going to steal the working out from the previous page. Just put it here for a second. So those are the odd numbers we had. And again, the prime numbers. And so now we want np to be a square number. So let's have a think of this. We need to think of two numbers, one yellow and one green, so that when you multiply one by the other, it gives a square number. As I said before, we don't need the numbers to be different. All we need is that n is in the yellow list and p is in the green list. So if you notice here, 3 is in each list. And so 3 times 3 would work, because obviously that's 3 squared. By the nature of a square number meaning a whole number multiplied by itself, what we need to do is just find a number that's in each list, really. So we could have 7 and 7 as well, because 7 is in both lists. So 7 times 7, that would be a square number. That's 7 squared. We could have 11 times 11, 13 times 13. Again, the point I'm making is there's lots of different combinations, and all you need is just to write down one combination which is valid. So you could go for 3 and 3, 7 and 7, doesn't particularly matter. But for the sake of argument, let's pick the first one I mentioned. So n could be 3, and p could be 3 as well. And that will do for question 20. Question 21. Joe's been bisecting an angle, or trying to at any rate. So he's wrote down his method. He says use a pair of compasses to draw arcs of the same radius from B and D, and draw a straight line from C through the intersection of the arcs. And so it seems reasonable what he's saying, but the key thing here is the first step is where the error's been made. So where he says use a pair of compasses to draw arcs of the same radius from B and D, that's just not right. If you do one from B and one from D, it won't work because B and D are different distances from C. So the error is B and D are not the same distance from C. So what we need first of all in this step, we need to draw arcs of the same radius from 2 points at equal distance from C, sorry. So B and D aren't the same distance. So what he should have done, I'm just going to show. So first of all, he needs to get his compass. He needs to put his compass on the line. Oops, just turn it slightly. Right, so what he needed to do is put his compass needle at C. Then he needed to do let's get it ready. Oops. There we go. You needed to do an arc from C which cuts CB and CD. So these 2 points are now the same distance from C. And so having done that, the next thing you needed to do was to do arcs from where this point crossed CD. So it needs to do a line here. And the same again at the other side where the intersection crossed the line CB. So what we need to do next is to put the compass on this intersection and do a straight line, sorry, an arc going from this intersection towards the middle of the angle. Once that's done, the next thing to do is to do a straight line out from C through that point, and that's a much better way of bisecting an angle. That is the main way of how to bisect an angle. That's actually split C into 2 equal parts, whereas here, in his example, this isn't split into 2 equal parts. This angle here is much smaller than this angle here. For part B, Kay wants to show all the points 3 kilometers from P, and her answer is this one here. So she's drawn a square. To put it simply, what's wrong with her answer? It should be a circle. So she should have constructed a circle. That's centered at P with a radius of 3 centimeters. So we can actually see this now. If I were to get a ruler, what she wants is to show the location of all points 3 kilometers from P. So if we get the ruler and move it here, we can see that that side is 3 centimeters from P, and if each centimetre is 1 kilometre, that's fine. But for corners are much further away. That's about 4.3 centimetres away, which wouldn't be 3 centimetres at all. That'd be too far. And so what she needed to have done was to have got a compass and set the compass to a width of 3 centimetres. I can just get it right about there, and it should have been a circle centered at P. So that's what it should have been, a circle, whereas she's actually drawn a square, which is completely different. And part C of question 21, we need to show a line of symmetry on this rectangle, and we need to clearly show the construction arcs. And so what we could do is do the perpendicular bisector of this top line. And so one way we could do this is to, again, get the compass handy and make sure the compass width is at least half the length between one end of the rectangle to the other. So what we can do here is put the compass on one end at one corner, and then we do a big sweeping arc from one end to the other like this. I'm going to move the compass over. I'm going to do the same thing from the other end. And what will happen is it will cross in two different places. Where the arcs intersect, what we then need to do is to draw a straight line going through the arced intersections. If we do that, what we'll have created is a line of symmetry for the rectangle. We could have also done the same thing at the other side and done a line of symmetry going along, but all we need is one line of symmetry, and so that would do for question 21. We can use the perpendicular bisector of one of the sides of the rectangle, and that line will be a line of symmetry. Question 22, we've got x in the ratio of y, and the ratio of 7 to 4, and we're told x plus y equals 88. And what we need to work out is what x minus y is. And so if we just do a table, or think about x and y in a table, so we'd have x and y. Now at the minute, we're told that for every 7 lots of x, we've got 4 lots of y. And at the minute, if we had the total of those two values, 7 plus 4 would be 11. But we know that's not right because we're told that x plus y equals 88. So we can use that fact to work out what x plus y must be. So it can't be 7 and 4 because that only gives us 11. We need it to give us 88. And so how many times bigger is 88 compared to 11? The answer is it's 8 times bigger. And so because we want the total to be 8 times bigger, we need to also multiply all numbers by the same figure. So we need to multiply the 4 by 8 and also multiply the 7 by 8 too. And so 7 times 8 is 56. 4 times 8 is 32. And so x and y is 56 and 32. So we can just highlight these now. So we know for definite that x is 56 and that y must be 32. So this question, you want to work out x minus y, which will be 56 take away 32. And 56 take away 32 we can do as column subtraction. 6 take away 2 is 4, 5 take away 3 is 2. And so x take away y must be 24. So that's our answer for 22. Question 23. Anil's home is 1 kilometre from a shop. He walked from home to the shop at a constant speed of 10 minutes. He stayed at the shop for 5 minutes. And then he walks home at constant speed, and it takes him 8 minutes. And so what we have to do now is to see what's gone wrong with his graph. Well, the first thing to spot is that it's saying here that he walked from home to the shop at a constant speed. So what we should be seeing is that the first part of the graph should be a straight line. So from 0 minutes to 10 minutes, that should be a straight line. A constant speed on a distance time graph is represented by a straight line. And so that's one criticism. So the constant speed in 10 minutes should be represented by a straight line. So we need to write that down. So the first part of the graph should be a straight line. A curve implies that he's slowing down as he gets closer and closer to the shop. He stayed at the shop for 10 minutes, so if he got there after 10 minutes and stayed for 5 minutes, he'd leave at 15, so that's fine. But then here it says he walked home at a constant speed in 8 minutes. So 15 minutes plus 8 would be 23. The timing's okay. This one's a bit harder to see, but if he walks home, his distance from home will decrease. So if he walks home, what will happen is he'll return to home, and once he gets to home, his distance from home will be 0. And so this line is a right steepness, if you like, but it's going in the complete opposite direction. So the second criticism is that the last part of the graph should be a straight line going downwards to 0 kilometers from home, because when he gets home he'll be 0 kilometers from home. As the graph stands, it looks like he's getting further and further away from home. So he's not going to be 2 kilometers from home at the end, he's going to be back home, he's going to be 0 kilometers away. And so that's the two criticisms there. Question 24, we've got 3 whole numbers and each have been rounded to the nearest 10. The sum of the rounded numbers is 70, so what we need to think about now is what the numbers could be after they've been rounded. So you can think of any 3 numbers if you'd like that add up to 70. So we could say they're 40, 20 and 10, because if you add them together they'll add up to 70. The question now is, what could these whole numbers have been before they were rounded? So 40, if it was rounded to the nearest 10, it could have been as big as 44. It couldn't be 45, because if a deciding digit is 5 or more, we round up. 45 would round to 50. So the biggest it could have been is 44. In the same way, if we pick 20, the biggest it could have been is 24, and if this number were 10, the biggest number it could be, with being rounded to the nearest 10 and still be 10, would be 14. Any bigger than 14, it would have rounded to 20 to the nearest 10. And so if we now add these numbers together, (44) plus 24 plus 14, what we'd get is a total of 82. Now this question, it doesn't matter what you decide for your initial numbers. So you could have picked 20, 20 and 30 and it still would have worked. The final total of the numbers would have been 82. So the three original numbers, for all we know, could have been 44, 24 and 14, which should give a total of 82. Question 25. Circle the expression for the range of n consecutive integers. Looks like integers, normally called integers. So an integer just means a whole number. The thing with integers is they can be negative, whereas natural numbers must be positive. So consecutive just means next to each other as well. So let's make a note of that in case you're not sure. Now the fact it says n just confuses things because it's hard to picture. So let's just say, for the sake of argument, maybe n equals 5. We don't know what n equals, but if n equals 5, let's pick 5 numbers. 5 whole numbers in a row that are next to each other. So maybe we can start at 6. So 5 consecutive integers starting from 6 could be 6, 7, 8, 9, and 10. Those are 5 consecutive integers where n is 5. 1, 2, 3, 4, 5. Now the range is always the biggest number take away the smallest. So in this case, the range will be 10 take away 6, which is 4. So when n is 5, when n is 5, the range is 4. We could try it for a different value of n, like for example if n were 7. It doesn't say where to start from, so we could start from wherever we wanted. Maybe we could even start from 100. The only thing that matters is the numbers need to be next to each other. They need to be consecutive. So if we started at 100, that would be 100, 101, 102, 103, 104, 105, and the 7th number would be 106. So I'm just making up examples just to explain. So if these were the 7 consecutive integers, then the range would be again the highest, which in this case is 106, take away the lowest, which is 100. The range would be 6. And so if n were 7, the range would be 6. So when n was 5, the range was 4. When n was 7, the range was 6. The range is always going to be 1 less than n. And so the range is whatever n is, take away 1. If you try real numbers, it makes it easier to get your head around. So that's why I've picked these real number examples. So the one we need to circle for question 25 is n minus 1. (26) We've got 3 identical isosceles triangles joined together to make a trapezium. Each triangle has base b and a perpendicular height of h. We need to work out an expression in terms of b and h for the area of the trapezium. So for this one, we're told that the isosceles triangles that make it are identical. So we can use that fact to our advantage. And so what we know, or what we should know, is that the area of a triangle equals half times base times height. So we can half at any time. In fact, what we normally might find it easier to do is half at the end. So base times height, and then we need to divide by 2 at some point. And so in this case, each triangle, the base is b because it says, and the height is h, all that divided by 2. Now in terms of algebra, b times h, we can just write b and h next to each other, and divided by 2, we can write all over 2. And so that's the area of one triangle. But because we've got 3 triangles, the area of 3 of these triangles will be 3 lots of BH over 2. And so we don't need a multiplication sign next to the B and H, we can just put 3 BH all over 2. So that's going to be our answer, 3 BH all over 2. Or if you wanted, you could even say it's 1.5 BH. Part B, we've got the same trapezium, but this time we've got a ratio. The ratio of B to S is 2 to 3. And so if we just take this ratio and write it up here, B to S 2 to 3. So ratios are typically easier when one of the numbers is a 1. And so if I can get that 2 to a 1, it will make the job easier. So how do I go from 2 down to 1? The answer is I can divide by 2. But if I divide this number by 2, I need to divide the S number by 2 as well. And so 3 divided by 2 is 1.5. By doing it this way, it just makes the ratio and relationship easier to see. And what this means is, if B is just 1, S is 1.5 times bigger than B. The reason I want to do that is because we want this in terms of B. So in terms of B, we can replace S with what S is equal to, which is 1.5B. And so B is along the top, and 2 lots of the base along the bottom. So that's B, and that's B. And the 2 sides, which are of length S, are going to be equal to 1.5B. So a total perimeter we can do now. Is going to be the total length all the way around the outside. So it's going to be B at the top, plus the 2 B's at the bottom, plus 2 lots of S, but S we're saying is the same as 1.5B. So you've got 1.5B plus another 1.5B. And so if we were to add up all these B's together, B plus B plus B is 3 B's. 1.5 plus 1.5 is 3. And so that would give us a total of 6B. So the total perimeter is going to be 6B. So the expression in terms of B, in our answer line, we put down 6B. Question 27, we've got a quarter circle of radius 6 centimetres. Work out the area of a quarter circle. Give your answer in terms of pi. That means we're going to leave pi in the answer. We're not going to substitute pi equals 3.14. We're going to leave pi, the symbol, in. So what we need to remember is the area of a circle. The way I remember it is to imagine pies. Now personally I'd say chicken pies, delicious, and if it's baked right, apple pies are too. So it's a silly way of remembering that circumference is pi multiplied by diameter, and the area is pi multiplied by the radius squared. If you're vegetarian, more respect to you, you could have called that a cherry pie. Cherry pie's delicious, apple pies are too. So the area formula is pi r squared. So the one we're interested in this case isn't the circumference, but we're interested in the area. So we need to know what the radiuses are. We're told that, luckily, that the radius is 6. And so for the full circle, because you need to remember we're not dealing with a full circle, but we'll come to that in a second. If this were a full circle, the area of it would be pi multiplied by the radius squared. The radius, as we've said, is 6, so that'd be pi multiplied by 6 squared. Now 6 squared is 36, and so pi times 6 squared is the same as pi times 36, which is just 36 pi. So now we can use that to work out the area of the quarter circle. So the area of a quarter circle, just remember, how do you find a quarter of something? What you do, you just take the full thing and you divide it by 4. And so this will simplify down. 36 pi divided by 4. We can just deal with the numbers here. 36 divided by 4 would give us 9. So the final answer to this would be, in terms of pi, the area of this quarter circle is 9 pi centimeters squared. Question 28. Write in standard form 12,500. So if I just put the number here, 12,500, the thing with standard form is the number appears in 2 parts. The first part of a number in standard form needs to be between 1 and 10. So we need to insert a decimal in this number so that it becomes between 1 and 10. So the question is, where would that decimal go? The decimal would have to go in between the 1 and the 2. If the decimal were there, that would make the number 1.25. The second part of standard form is a power of 10. So the first part is a number between 1 and 10, which we've now got. We're now going to multiply that by 10 to a certain whole number. And the way we do this is we have a look where the decimal needs to go and compare it to where the decimal actually is. Now, a whole number doesn't need a decimal, but if you wanted to include a decimal in a whole number, it would always go at the end. So 12,500 we can picture like this, with a decimal at the end of the final 0. Now what we do, we can compare where the decimal needs to go to where the decimal actually is in the original number. And then we count how many digits are between where the decimal needs to be and where the decimal actually is. So if we count now, there's 1, 2, 3, 4 digits between. And so the power of 10 is going to be 4. Because we've got a 2, a 5 and 2 zeros in between where the decimal is and where the decimal needs to go. And remember, it's a positive power of 10 if we're talking a big number, so 10 or more. It's a negative power of 10 if we're talking about a small number, for example 0 point something. Speaking of negative powers, this is what we're dealing with in part B. This power of 10 is negative 2. The way we write this as an ordinary number is we write the number out as it stands, so it's 3.4. And then the decimal is going to move 2 numbers to the left. Minus means we're going to move the decimal 2 numbers to the left. So it's going to go over the 3 and jump over nothing. Now nothing in maths is a 0. So the decimal will land here. Because it's a -2, we move 2 numbers left. Decimal was there, it'll end up here. So the answer to this one would be 0.034. Again, an even quicker way of doing this, if you want to write as an ordinary number something in standard form and it's a minus power, whatever the minus power is will tell you how many zeros need to be before the first non-zero digit. So because that's a -2, notice how we've got 2 zeros before the 3? That's not a coincidence. So we've practiced with standard form, converting from standard form to ordinary numbers, and from ordinary numbers to standard form. It is something that you can master with lots of practice, because there are quite a lot of nice shortcuts and tricks like this one. Question 29, we need to work out the value of square root of 3 all squared multiplied by the square root of 2 all squared. Essentially what you need to think of here is that square root and squared are inverse operations. So one undoes the other. It makes it easy to see if we were to pick nicer numbers. So for example, if we had the square root of 4 squared, remember BIDMAS, try and work out the brackets first if you can. The square root of 4 would be 2, because 2 times 2 is 4. Then we can do 2 squared, which is 2 times 2, which is 4. And so because we are squaring a square root, in a sense, the squaring cancels out the square root at all, and you're just left with what you ended up with. So we had a 4 underneath the square root symbol, and that's what we'd end up with here. So just because these numbers are more awkward doesn't make this any less true. So what will happen is square root of 3 squared will just end up with a 3. In the same way, with this example, we just ended up with a 4. And over here, the square root of 2 squared will just end up with a 2. And so this becomes 3 times 2, which is 6. And so it's a horribly worded question in a way, because it seems much more confusing than what it is. But if you think about it and take a step back, it's not actually too difficult a question. The key thing is remembering that if you square root something and then square it, you get back to the number you started off with in the first place. And so that one is just simply 3 times 2, which is 6. Question 30, one of the last 2 questions now. We've got 4 candidates in an election, A, B, C and D. I've got a pie chart showing the proportion of votes for each candidate. What we need to do here is to work out the probability that a person who voted, chosen at random, voted for C. So the key here is we've got all these different x's, and so something tells me it's going to involve an equation. And so what I'm going to do here is just colour code for different bits on this pie chart. So we've got an x here. Over here we have a 2x. And the biggest sector has an angle of 2x plus 10. Now we need to remember some angle facts, in particular angles in a circle. Angles in a pie chart and angles all the way around a circle will always add up to 360 degrees. So just to make a note of that, total of angles in a pie chart is 360 degrees. And so if we add up all these here, it will come to 360 degrees. It's got to. This little square means it's a right angle. A right angle is 90 degrees. Then plus x, and plus 2x, and then plus 2x plus 10, that's all the angles added together. So all of those must come to 360, because angles in a circle will always add up to that. So that was a right angle, we have x, 2x, and finally the big purple one was 2x plus 10. Now what we can do is simplify this part of the equation. And so have a look at the x's. We've got 1x here, plus another 2x's, plus another 2x's. That would give us a total of 5x's, and 90 plus 10 gives us 100. And so once we simplify this down, what we'd get is 5x plus 100 equals 360. This is now an equation we need to solve. We want to have x on its own, so what we need to do is take this plus 100 to the other side of the equation, and when we swap the side, we swap the sign to a minus. And so now we're going to have 5x's equals 360 take away 100, which is 260. We don't want 5x's though, we want to have just 1x. And so in the same way, that 5 is multiplying the x, so if we swap the side, it will swap the sign to the opposite of multiply, which is divide. And so x is going to be 260 divided by 5, which I'm just going to do over here using the bus stop method for you. 5's into 2 won't fit, and so we've got a remainder of 2. Now 5's into 26, we can fit 5. 5 5's are 25, which is still 1 away from 26, and so the final remainder is 1. Now 5's into 10 goes 2, and so x will equal 52. We're nearly done but aren't quite, because we want to work out those that voted for C. The ones that voted for C are these ones here, which is the purple sector. And so we need to work out what 2x plus 10 is. If x is 52, then 2x plus 10 will mean 2 lots of 52, which is 104, plus an extra 10, which gives us 114. And so what that means is the purple angle is going to be 114 degrees. But we want to state the probability that a person who voted, if they're chosen at random, voted for C. Now, with a pie chart, the proportion of votes will reflect exactly the probability of that particular person being chosen. So the proportion of people that voted for C was 114. 114 degrees out of a total of 360. And that's all we need to do. The probability of C is the same as a relative proportion of votes for C, which will be 114 degrees out of a total of 360. And so that's that question done. The last question, we can breathe a sigh of relief. Part A, factorise x squared minus 100. This one here is called the difference of two squares. If we start with a squared thing, x squared, and we're taking away a number which is also a square number, this is called a special case of factorising. It's called the difference of two squares. And the way these are factorised is very easy if you revise them. The little tip here that it's going to be easy is that it's a 1-mark question. The way it's done is the positive square goes in the bracket first. So we open up 2 brackets and put an x at the beginning of each. The second thing we do is think about what would the square root of 100 be? What number multiplied by itself would give us 100? The answer to that is 10. And so the last thing we put in the brackets is a 10. So the square root of x squared at the beginning, the square root of the minus thing at the end. Then all we do is in one bracket we have a plus between the terms, in the other one we have a minus between the terms, and that's all there is to it. So the answer is x plus 10 brackets x minus 10. Now part B was solving an inequality, but what I want to show you is that inequalities can be solved in exactly the same way as equations. So we're going to call this an equals. Just bear in mind though, it's not really an equals, but for all intents and purposes it can be treated as such for solving the equations. This one here, we've got x's on both sides of the equation, which is unsolvable. So what we need to do is to bring all the x's together to the same side. If we take away the 2x from this side and move it over here, if we swap the side, we swap the sign. Opposite of plus 2x, positive 2x will be minus 2x. And so what will happen on this side, we'll have only 5x now, because 7x take away 2 is 5, plus 6 equals 1. I'm putting the equals in red just as a warning, to remember it wasn't really an equals. So now we've got the x's on one side, we want on the other side to have all the numbers together. And so this plus 6 can go over and join that 1. But once again, if we swap the side, we swap the sign. Opposite of plus is minus. And so what we'd have now is that 5x equals 1 take away 6, which is minus 5. If I just take this bit here to make some more space, just pop it down here, 5x equals minus 5. So we're nearly done, but we want just x on its own. So what we need to do is to divide both sides by 5. Again, we can think of that 5, which is multiplying the x, as swapping side and swapping sign. Opposite of multiply is divide. If it were 5 divided by 5, that would be 1. But because that's a minus 5, it makes x minus 1. But just remember what I said at the beginning. It wasn't really an equals, was it? So the final step, really important, take out the equals and just put back into place exactly what symbol it was, facing the same way round. And there we have it. So the answer is x must be greater than minus 1. And that's the whole exam done. I hope you found it useful. Feel free to comment and keep up with that revision.